Now, good morning, everybody. So we'll be continuing from our exercise on error analysis. So we're looking at question 6. The following time measured, following time, question 6. The following time measurements were made in the lab: 20.1, 20.2, 20.3, 20.2, 20.0, 20.2 seconds. Find the mean value of the period of oscillation and the standard error in its value. Now, first thing first, you know how to calculate your mean. Your mean is simply the sum of the data given divided by the number of data in the work we're given. Now, here we have 20.1 plus 20.2 plus 20.3 plus 20.2 plus 20.0 plus 20.2 divided by 6. So when you add up and divide by 6, the mean value will be 20.2 seconds. Now, the standard error is simply the deviation from the mean divided by the total number of occurrence in the data. So our T here is simply the T values you were given in the question. While your T bar here simply means the mean value you are given. So you subtract your T bar from your T, then you square the results and divide it by 6. That is the total number of occurrence there. So when you do that, we'll see that our standard error in the mean is 0.01 seconds. So that's 0.2 plus or minus 0.01 seconds. Now the next question, we have the following measurements were made to determine the density of steel sphere with estimate of standard errors indicated. Now the first thing, we're given the mass of the steel as 0.370 plus or minus 0.001 kilogram, and radius of the sphere to be 0.0223 plus or minus 0.00001 meter. We're asked to deduce the density of the sphere and the uncertainty in the radius. Now the next thing, what we're supposed to do here is this. The density, like we know, is defined as mass divided by volume, and the volume of a sphere is defined as 4/3 pi r cube. So we have to calculate the volume, putting our value for r there. So we'll get 4.646 times 10 raised to power minus 5 meter cube. Now the error from here, we see that 4/3 is a constant, pi is a constant. So the only value, the error in the volume is S subscript V divided by the volume itself. 3 SR divided by R. The reason why we're having 3 here is because our radius here is being cubed. So on making S be subject of formula, we'll multiply V by the error in the radius. So on doing that, we see that our error in volume is 10 raised to power minus 7 meter cube. Now, the volume now is the actual volume plus or minus the error we got there. Now, the next thing we have to do there is to calculate the density, since we've gotten our mass and we have our volume now. So on calculating the density, we have density equals to mass over volume. Our mass is 0.370 divided by our volume is 4.646 times 10 to the power minus 5. So on dividing, we have this. Now the next thing is to find the uncertainty in the results. That is the uncertainty in the density. Now the density, we're having 3 variables here: density, mass, and the volume. So to calculate the uncertainty, we're using this formula, the same formula you came across with in previous examples. So we'll make the density, the uncertainty in the density subject of formula. There will multiply error in mass over the mass squared, standard error in volume over the volume all squared, and point error in the density of the material of the sphere. Now the next question here says, in the following set of repeated readings, that is 24.3, 24.8, 24.2, 24.4, 24.6, 24.1, 26.4.6, 24.7, 24.6, 24.7. We are asked to calculate the mean value, the range, and the standard error of the mean. Now, these are the values we were given. The mean value is simply adding up everything and dividing it by the total number of data there. And the total number of data there is 10. So on R5. Now, the next thing is to calculate the range. The range is simply the difference between the highest value, which is 24.8, and the least value, which is 24.1. So on subtracting, we have 24.7 as our range. Now, the next thing is to calculate the standard error in the mean. It's simply 1 over n times the summation in the deviation, in the square of the deviation from the mean. What does that mean is that we will subtract our mean value from the value of x we are given, square it, and sum up everything, then divide it by the number of data we have in there, which is 10. So this is how it is done. On doing that, we have that our value, our answer gives us 0.0505 as our standard error in the mean. Now the next question here says, the following are the dimension of a microscope slide. The length and the thickness is given as this. We have to calculate the density of the material of the slide and the total possible error involved. Now we've been given the length, we've been given the breadth, and we've been given the thickness. We know our density is mass divided by volume. Now we're going to assume that the mass and the standard error in the mass of the material in the slide is 1 plus or minus 0.001 kilogram. Then the volume is simply length times breadth times thickness, which will add this in centimeter cube. Now, the error in the volume is given as this. The error in the volume is given as this. Just pardon this double plus sign there. It's supposed to be a single plus. So the error is given as this, and the standard error in the volume is given as this by making S be subject of a formula there. Now, we have that on substituting, we have this there. Now, to calculate our density, now we have mass divided by volume. We are keeping it in kilogram per centimeter cube. Then the density is the same formula we used in the initial problem when we were solving for standard error in density. Then we're fixing our values for standard error in mass, standard error in volume, and the volume. We have that our standard error in the density is taken as this. This is our possible error in the measurement of the standard error in volume there. Now, the last question here says the following reading are obtained in an experiment. H is given as these values here. N is given as these values here. We are asked to calculate the plot a graph of H against N, measure the slope, estimate the standard error in the slope, and if N and H are connected by the equation H equals to NC, where C is a constant, deduce the value of C and the standard error. So here, it simply means that if we're plotting H against N from our linearization of graph, we see that C here becomes the slope of the graph. Y equals to mx plus c. We see that y and x are the variable, m there is a slope of the graph. So in this case, h and n are the variables. C here gives us the slope of the graph. Now, plotting the graph, the scale we are to use, first you need to title your graph H against N, and we'll label the axis H and N here. Now, the scale we are to use 2 centimeters to 1 unit on the H axis and 2 centimeters to 4 units on the N axis. Now, on plotting the graph, to maximize our graph here, we see that our graph is given as this, and the line plotted is line of best fit. Here I'm having one, and here outside here I'm having another one, not entering the points here. So it's a line of best fit, but we're not asked to calculate the error in the slope. So we can neglect these dotted lines here. So on calculating it, here we have our H here. Our maximum value for H here is 7.2. Then H1 here is 1.8. N2 here is 16. N1 here is 4. So to calculate our slope here, we have 7.2 minus 1.8 is 5.2. 16 minus 4 is 12. So on calculating that, we have 0.45 as our value there. So the error in the slope. So we have to calculate the error in the slope. Our vertical scatter is just this distance between the points here. So we can take any point. I can decide to take this point and just these points here. So measuring it, we see that our vertical scatter W is 0.2. On measuring the distance on our vertical scatter, the number of points plotted is M5. Our R is the range on the horizontal axis, which we have as this 18 minus 4, which will give us 14 there. So on putting that there, we see that our error in slope is 0.01. Now the next thing here, we're having our relationship between H, N, and C. So the relationship is given as against N. The slope is equals to what? C. If we compare with Y equals to mx plus C. Now here, your Y here is H, your X here becomes the slope, which is our M here. So therefore, your C, value for C does not need to be calculated since you've gotten our slope here. Since C equals to slope. So C equals to 0.45. And the error in the slope give us the error in C, which equals to 0.01 as our error in C. So thank you for watching. Let's have a beautiful holiday.